So right now we are studying geography. So atmosphere. So related everything to atmosphere right now, right? Take it. Here it is no, I think. Okay. So atmosphere, no, nitrogen, oxygen 70%, argon 0.1, so plasma 0.78 to 0.40, 0.0 CO2, NOAA, CNH, KX2. So क्या क्या है सबसे ज़्यादा it's NOAA, okay. So it's nitrogen, oxygen, argon, and then CO2 of course. Then नहीं NH, so it's no AC, yeah, no AC. Okay, ऊपर में कोई AC, so it's no AC. Then it's the, so no AC, HKX, ठीक है. So water vapor wettest एरिया में इक्वेटर में सबसे ज़्यादा ऑफकोर्स 4% एंड ड्राइड एरिया इज 1% टन, ठीक है. दस पार्टिकल्स हाइग्रोस्कोपिक न्यूक्लाई, 10 पार्टिकल्स का हाइग्रोस्कोपिक पार्टिकल्स होता है क्योंकि हाइग्रोस्कोपिक फीचर्स होता है बिकॉज इट अट्रैक्ट्स मॉलिक्यूल वाटर मॉलिक्यूल्स टुवर्ड्स इटसेल्फ. So and thus it helps in the formation of the cloud. Okay, so this particles at tropical desert. Okay, temperature reason hygroscopic nuclei attract water particles and that helps in the formation of the cloud. Then troposphere. So we're right now we're into the layers of the atmosphere. Troposphere equator पे कितना होता है, poles पे कितना होता है, that we should know. थिकनेस ज़्यादा पोल्स पे होगा क्योंकि कन्वेक्शन कम होता है, एयर बहुत कम राइज करता है. So troposphere 8 to 18 kilometer. Total overall height of the troposphere is 8 to 18 kilometer. So at equator it is 18 kilometer and at pole is 8 kilometer. Yes. So thickness. So at equator wise 18 kilometer क्योंकि एयर बहुत ज़्यादा राइज अप होता है बिकॉज ऑफ हाई रेट ऑफ कन्वेक्शन. सो एयर ज़्यादा राइज अप होता है इसलिए ऊपर ज़्यादा एयर, तो इसलिए ट्रोपोस्फियर ज़्यादा लेंथ का होता है. एट इक्वेटर इट इज 18 किलोमीटर. सर ऐसे होगा. सो 8 किलोमीटर होगा. नो चेंज इक्वेटर बिकॉज द टेम्परेचर. सो इक्वेटर पे कोई चेंज नहीं होता है टेम्परेचर में ट्रोपोस्फियर में क्योंकि ऑफकोर्स समर विंटर का कोई इफेक्ट नहीं होता है क्योंकि द रीजन रिसीव्स the sunlight at during the winter season as well as summer season. Is not impacted by the winter and summer season. Okay, so the temperature at equator minus 80 degree Celsius and at the poles of course minus 45. So all these are datas. So ये लेयर में क्या क्या रहता है, गैसेस रहते हैं ऑफकोर्स ट्रोपोस्फेयर में. यहीं पे क्लाइमेटिक कंडीशंस भी अगर होता है और सबसे इंपॉर्टेंट गैस और वाटर वेपर डस्ट पार्टिकल्स यही लेयर में फाइंड किया जाता है, उसके ऊपर लेयर में नहीं मिलता है. सो दिस इज अ वेरी इंपॉर्टेंट कॉन्सेप्ट. वाटर वेपर डस्ट पार्टिकल्स ओनली इन दिस लेयर and other gases like no AC. By no AC I mean nitrogen, oxygen, argon, carbon dioxide. So that's how we arrange the gases. Then we move to a stratosphere. So troposphere 8 to 18 kilometer. Okay, 18 kilometer, yes. सो नाउ मूविंग टू स्ट्रेटोस्फीयर जस्ट लेयर अबव था जहाँ पे एरोप्लेन्स फ्लाई करते हैं बिकॉज क्लाउड का इतना डिस्टर्बेंस नहीं होता है, क्लियर वेदर मिलता है. सिंपल एज दैट. सो फ्री फ्रॉम वेदर डिस्टर्बेंसेज ऑफकोर्स बिकॉज ऑफ द हीट, सन एंड रेनफॉल एंड नथिंग मोर देन दैट. एवरीथिंग इज रिलेटेड टू सन. free from weather disturbances. Height 50 kilometer. Ozone formation, heating of this layer. Ozone, ultraviolet, ठीक BNC. So ultraviolet radiation, BNC are present here. So ultraviolet BNC are stored here. Ultraviolet A is allowed to pass. So that's 80 kilometers. So 8 to 18 kilometer, 50 kilometers. Okay, 50 kilometer. The mesosphere will be 80 kilometer. Temperature will decrease in this layer, will minus 100 degrees Celsius, and it's naturally occurring. There is no definition for as such why the temperature is decreasing. Just change this. Mesosphere 80 kilometer, temperature decreases. So thermosphere ions 400 kilometer. Air is very thin because of atmosphere. Temperature 1500 degrees. Pace will start from here. So we have the troposphere 8 to 18 kilometer. Stratosphere 50 kilometer below. Up 50 kilometer. Mesosphere 80 kilometer below. Mesosphere temperature will decrease here, naturally occurring. Thermosphere it is also known as ionosphere. There is 400 kilometer. Air is very thin here because light gases 3500 kilometer. 400 kilometers. जैसे का 400 चले जाओ, then 3500. ठीक है, 50, 80, 400 किलोमीटर हो गया. लेयर ओशन currents and all, because hygroscopic nuclear notification not written it. मैं याद रहेगा. ये बताइए मेरे perpendicular or the slope of the mountains. Forward is forced and greenhouse gas cannot trap high energy radiation. That is shortwave radiation traps low energy radiation. It is a terrestrial radiation. Solar radiation reaching the earth to you. How the solar radiation is to ultraviolet rays, infrared rays, visible light rays. UV, infrared and visible light. Infrared rays can penetrate dust and fog. Yes. Fine soil particles, sea salt, ocean smoke, ash. Okay. What are the characteristics of dust particles? Generally found at lower levels, hygroscopic nuclear higher concentration. Okay. So if you ask about the characteristics of the dust particles, it's generally found in lower vertical latitude, longitude, temperature, everything is so high definition. Volcanic eruption. Of dust particles, so they are generally found at the lower level. They act as a hygroscopic nuclear. That means they attract the water molecules and leads to formation of the cloud. They are found at a tropical desert and temperate region, and they help in the scattering of the sunlight, giving the blue color to the sky. Change the color. ठीक है, छोड़ो भी पढ़ लेते हैं बेटिया तो कौन इन द lower level concentration so vertical structure of the atmosphere. So what is the vertical structure of the atmosphere? That is the temperature and the chemical composition. So what is the total what is the overall chemical composition of the atmosphere? No AC as well, nitrogen, oxygen, argon, CO2, and temperature we know depending on the short wave radiation of the sun and the long wave radiation of long wave terrestrial radiation. Okay. Focus is a layer of the mixing of the air in the atmosphere, and it is 18 kilometers. So temperature decreases at the lab. So as you go higher, the temperature will decrease at the lab speed 0 to 90 degrees. Okay. It's better now. So temperature, troposphere is a layer of the mixing of the atmosphere. So at the poles it is 8 kilometer because air is very dense there, and at the equator is a high rate of convection, so air will rise to a higher level, and therefore it's at 18 kilometer. So as you go higher, the temperature decreases lapses. Okay, troposphere is a layer of the mixing in the atmosphere. 10 kilometer at the poles, it's somewhere at 8 kilometer. And as at the equator, the air tend to rise over because of the high temperature, high rate of convection. The air tend to come down due to cold temperature. The troposphere at 8 kilometer. Okay, air gets cool by either transferring the heat or expansion. So how does air get cold? So it rises up and the temperature decreases, it gets cool. So how? By transferring the heat or by expansion. So it's either by transferring the heat or by expansion. The top layer is called the tropopause, where the troposphere comes to end. The tropopause in the equator has the temperature of minus 80 degrees Celsius. Tropopause is minus 80 degrees Celsius because it will be colder because the hot air is rising, it's becoming cold by transferring the heat, and the pole is for minus 45 degrees Celsius. All the climatic as well as weather changes takes place in the tropopause. Okay. Water vapor and dust particles also found in this layer. Temperature change in the troposphere 400 kilometer. The height of the troposphere does not vary. Equator during summer. Okay. The height of the troposphere does not vary in equator. Why? Of course, because the temperature does not change during the summer and the winter season. The height of the troposphere vary at the average 13 km mid latitude region in the winter and the summer. Yes, season. The stratosphere, it extends up to height of 50 km from the ground. This layer contains the ozone gases, ultraviolet B, and what was ultraviolet radiation? A radiation, right? Yes. It allows the ultraviolet A radiation to pass, not B and C. This layer contains ozone gas, okay, which extend from 10 km to 50 km, but most concentrated in 15 to 35 km. Ozone is also a greenhouse gas, of course. Ozone, water vapor, all these are greenhouse gas. Hence, it absorbs the radiation. So, all the greenhouse gas, what it will do, it will of course absorb the radiation. Water vapor will absorb the radiation, but long wave radiation, very little the short wave radiation, that is the solar radiation. primarily the terrestrial radiation, that is a long wave radiation. But most considered 50 to 35 kilometer. Ozone is also greenhouse gas, hence it absorbs the radiation. Okay, it absorbs UV radiation and releases heat radiation by breaking the molecules. So it breaks the molecules of the oxygen to form ozone. I mean, oxygen reacts with the ultraviolet rays of the sun, to form ozone. It absorbs UV radiation, releases heat radiation by breaking the molecule of ozone. Hence, ozone heats up the atmosphere. So that's why it releases heat. While the process of breaking of the oxygen molecules reacting with the ultraviolet rays, it releases some amount of it. That's why it leads to warming of the stratosphere, and that's why we see the stratosphere is comparatively warmer than troposphere. So ozone cycle, overall ozone absorbs to ultraviolet radiation, that is B and C. Does not absorb ultraviolet radiation A because A is allowed to pass. What they absorb is the B and C. 5 minutes. Okay. Okay, a break. Okay, A break the ozone to oxygen and releases heat, and second combine the oxygen to form ozone. So first it breaks, then it combines. Then that's it. A break the ozone to oxygen. So first they will break the ozone to oxygen and then release heat, and second combine the oxygen to form ozone. So first it will combine with oxygen to form, then it will break the ozone to oxygen. That's why there is the formation of ozone, oxygen, ozone, combine with the oxygen to form ozone. Okay. So O3 is a process. In the process heats up the and this in the process, in combining and breaking it heats up the stratosphere. So in the stratosphere, so oxygen is the ultraviolet rays, कुछ तो है नहीं, सिर्फ गैस और सन है, उसी के ऊपर में सारा काम करना है. In the stratosphere, as vertically rises, the temperature will rise. Beyond the stratosphere, tropopause comes in. Now there is a tropopause, all the things will come to. And now mesosphere, it was I think 50 kilometer. It will be somewhere in 80 kilometer. Yes, so extend up to 80 kilometer from the ground. In this layer, because no ozone is present, the temperature goes on to decrease, and the temperature might reach up to minus 100 degrees Celsius. So no ozone, no oxygen is not present, so temperature will decrease. There is no as such chemical process or happening here, so there is no heating or heating of the surface. Wherever there is a chemical process happening, so there will be some amount of heating. This is naturally occurring coldest temperature anywhere in the so break the ozone to form oxygen, then combine with the oxygen to form ozone. Ultraviolet rays A primarily. I mean, sorry, it's A is allowed to pass. Is B and C. Okay. Okay. So thermosphere is 3000, somewhere like 3000. It's 400 kilometer. Yes, thermosphere is 400. Exosphere is somewhere 3000. Okay, 2 minutes. Thermosphere has a layer of ions. Okay, so in the thermosphere there is a layer of the ionized particles, that is released by the sun, which is called ionosphere, and they extend up to the height of 400. Okay, I know this. This layer gets heated because the air is very thin. There is no atmosphere. Now we're moving towards space. Now we'll be moving towards space. And this is the sun radiation in the form of short waves. Yes, scattering. Okay, the temperature can reach up to 1500 degrees Celsius. Okay, this is the amount of temperature in the thermosphere. The temperature can reach up to 1500 degrees Celsius. Because of the heat, air particle can become ionized, and when the ionized air particle come in contact with the solar winds, so these are the ions, which is that is released by the sun, the surface, the atmosphere of the sun. And here only we see the phenomena of the aurora borealis in Sweden, Norway, when you go to the North Pole, because when this ionized particles are released by the sun, and it's present in the it forms the ionosphere and thermosphere region. Then what happens, the magnetic field is formed, because the magnetic field protects the earth from the ionized particles of the sun. So magnetic field is formed, and due to which we see different types of colors are released due to some amount of presence, some amount of gases. And when magnetic field is formed, so that's what we call as aurora borealis and aurora australis in Australia, north and south, in both the hemisphere. The temperature can reach up to 15 degrees because of the heat. Air particle can become ionized, and when the ionized air particle come to contact with solar winds in zones when the Earth's magnetosphere. That's what I said. And just all these things are not written in my notes. These are free knowledge. Hmm. Okay, because of the heat, air particle can become ionized, and when the ionized air particle come in contact with solar winds in zones done. Particle comes in the when the ionized particle comes in contact, aurora is formed. Aurora australis, aurora borealis. Those ionosphere comes in contact with the charged particles in area where magnetic field is not reflected. The ionosphere also reflects back the radio wave signal, mostly short wave and medium wave. So this ionosphere also reflects back the radio wave signal. This is important for communication. Gases are present. It extends up to 3,500 km. Temperature increases here up to 5,000 degrees Celsius. On the basis of the chemical composition, there are mainly two layers in the homosphere and heterosphere. Homosphere extends to 888 km. Air in the homosphere has uniform composition. Okay. So this was on the basis of vertical structure of the atmosphere, that was related to chemical composition and temperature. Primarily with respect to temperature. And I'm going to have tea because I'm really craving for tea, and I'm actually tired. I'll come back again.